we will try to understand the circular motion. What is circular motion? Motion of a body along a circular path is known as circular motion. If a body is traveling along an arc of a circle, is in circular motion, it is not necessary for a body to perform or to trace whole path of a circle. If it is traveling along a arc or a part of a circle, it is in circular motion. Now, uniform circular motion. What is uniform circular motion? Motion of a body along a circular path with constant speed is called uniform circular motion. With constant speed. Here we have to understand the velocity is not constant because it is continuously changing its direction, but the speed of the body is constant. Due to change in direction of velocity, there is a acceleration. It is called centripetal acceleration. A body in circular motion is described by two physical quantities. First, speed of the body, velocity of the body, v. Second, radius of circular path. For uniform circular motion, body needs a lateral force such that it continuously changes its direction. This force is called centripetal force. Centripetal force is defined as the radial force directed towards the center, acting on a body in circular motion. It is called centripetal force. What is the nature of centripetal force? First, magnitude of centripetal force remains constant. Second, always it acts along the radius. Third, it is always directed towards the center. Hence, centripetal force is radial force of constant magnitude. The centripetal force F acting on a body of mass m moving in a circular path is given by centripetal force is equal to mass into square of velocity divided by radius. What is centripetal acceleration? It is equal to the square of velocity divided by radius. What is the relation between centripetal force and mass? First, if an object swinging in a circle with constant speed requires certain amount of centripetal force. If the mass of the body is doubled, then required centripetal force is also doubled. If the mass of the body is tripled, then required centripetal force is also tripled. It means if the mass of the body increases, then centripetal force is also increasing in a proportionate manner. Hence, centripetal force is directly proportional to the mass of the body. And what is the relation between centripetal force and radius? Consider an object of mass m swinging in a circle with a constant speed requires certain amount of centripetal force. If the radius of circle is doubled, then required centripetal force is halved. Radius is equal to 2 times radius, then centripetal force is half. If the radius of circle is half, then required centripetal force is doubled. It means if the radius of a circle is increasing, the centripetal force is decreasing, and when radius is decreasing, the centripetal force is increasing. Hence, centripetal force is inversely proportional to the radius of the body. Centripetal force and the speed. Consider an object of mass m swinging in a circle of radius r with certain speed requires certain amount of centripetal force. If the speed is doubled, then required centripetal force is increased by 4 times. If the speed is tripled, then centripetal force is increased by 9 times. Hence, centripetal force is directly proportional to the square of the velocity of the body. What happens if centripetal force is stopped? The body is moving in a circular path. If the centripetal force is stopped, the body moves along the tangent to the circle. It starts performing linear motion along the tangent. If the centripetal force is stopped, the body moves along the tangent to the circle with a velocity v. Why? This is in accordance with Newton's first law of motion. When there is no centripetal force, then there cannot be any change in the direction of the body. Hence, it moves in a straight line along the tangent to the circle.